Okay, so let's get into it. Just checking the stream quickly. Seems to be going. So, this week's assignment is called Dividing Out Time. The reason why it's called Dividing Out Time is because we're going to do two things with it. We're going to work on our division. So we're going to take what we did last week and expand it and actually put it into practice using division strategy and using long division. And then we're also going to have a look, just a bit more dedicated look at using multiplication to work out area. Okay, so that's the two things that the other two things we're going to be doing this week. So let's get into it. So first, what I'm going to do is I'm going to talk you through division strategy. I'm going to start with something really simple. I'll start with a version of the very first question, okay? So you can see how easy it can be. Oopsie, that's not it at all. Just delete what I have up there, put to that, change the colors. I still haven't really figured out how to use this program fast, but I had a wee look and was struggling to find a better program, so here I am still using it. Okay, so the first question was 15 divided by 2. Now I'm not going to do that exact one, but I'm going to do one that has a similar kind of concept. So the actual reality is that we know 2 times 7 is 14. So what I'm going to do is I'm going to do 22 divided by 3. So it's a very similar question because that's actually a slightly harder question, but you'll get the idea. Okay, so I said I was going to do 22 divided by 3. So first I'm going to get my thing. I'm going to write my 22 is my big number, and my 3 is this number. Now, I don't know why I just wrote 6. That's beyond even my understanding. The thing to remember about these problems is always looking for an easier way to solve them. So, is there a number that I can multiply this by and multiply this one by and make it easier? You know, and that becomes a lot more important once you're into your decimals. But as this is, it's not a very hard equation as it is. So what we're going to do is we're going to go through the process of what I do. Okay, so the first thing is to initially think I'm working with my 3 times tables. Okay, now if you don't know your 3 times tables, well, it's time to practice. But if you don't know them, you would write them up the side of your page to help. 3, 6, 9, 12, 15, 18, 21. And if you think about that, it's 3 is 1 times 3, 6, 9, 12, 18, 21. That doesn't sound right at all. 3, 6, 9, 12, 15, 18, 21. It's 7. I don't know where I lost my fingers in there, but I'm sure you guys will laugh about it when you see it back on the video. So I know that it goes in 7 times. So first I'm going to start with that. So I know that it goes in 7 times, but I've got a remainder of 1. Now, I'm not teaching you to get remainders. That's kind of not the point at all. So I'm going to write this remainder right here. Now, does 3 go into 1? Well, if you know your fractions well, you actually know that that makes 1/3, and 1/3 is 0.333333 recurring forever. But let's just do it as an actual equation for now. So when some people will look at that and know straight away that that is 1/3, and they won't actually need to do the rest of the equation because they can figure it out. But let's pretend that we don't know that. So no, it doesn't go on to 1. So your next step is simple. You can add a free O, but that means you have to put a decimal on. So because I've added a 0 there, I have to put a decimal here. So we're working in the decimal area. So now, does 3 go into 10? Yes, it goes into 10 3 times. And then what's left over? 1 again. Now I can add my 3 O. Now I've got the same problem again. Now you can add 1 0 for free. If you have to add 2 zeros to fit it in, oh my goodness, it doesn't. We'll talk about that when we get to one of the harder problems, because some people may only get to these problems. You know, always when I give you work, guys, it's graduated. So if you get to, you know, let's say you do the first line. The first line, I want everybody in our group to be able to do. Halfway through the second line, I feel like you should be able to do these two. Starting into these ones, if you can't do them, that's okay. It's not, you know, like, that's fine, because some of those they're quite hard in some ways. Okay, so I just want you to, you know, if you have a go, but don't go into panic zones if you can't answer those sort of questions. Okay, cool. Keep on going to literacy, so I better cross that out. So then I've got the same problem again. What's left over? I've got a 1 left over, and the 3's just carry on forever, because 3 goes into 10 3 times. So then I'd have a 1 left over, then I get a free 0, which then makes another 3, and that 3 just carries on forever. So the answer to that, I'm totally happy with. Any of your ones is leaving your answer at 2 decimal points. So I would accept an answer of 7.33. Now, for all of these equations, once you've done them, I expect you to mark them, because I am marking your working and your ability to work them out. So I'll see your working, but I expect you to go, okay, now that I've done it, I've seen my working, I'm just going to do the equation, which is 22 divided by 3, just like that, and hold it. And you don't have to, you just mark your own, like I'm holding it up to the camera, showing you that I've done it, and I've done it right, but you just need to tick yours or cross it. And if it's crossed, and you're continually getting crosses, then you need to ask for help. Email me. Put your hand up when I'm walking around the room. I'm there to help. I really want to help. Yeah, so that's how you should be approaching these questions. So that's the division process. I'm going to show you it again with a not too hard one again, just so that we don't get too far ahead of ourselves. I'll do one that's similar to this one, 20s into 31. I'm not going to do 20s into 31 because then I'd be giving you the answer, but I'll do something similar to it. I'll increase my size and delete that. Rub out the old. So now, the 20s, I'm not going to do 20s into 31 because that's just like, it's a little bit easier than what I want to show you. So what I'm going to do is I'm going to do 21 into 21s into 33. That's a little bit more nasty than what I've given you. But actually it's not that bad. But let's just say it is. So that's an awful 33, so I hope you can forgive me for that awful 33. But let's just go through the process again. So the first thing we need to do is make sure that there's not some simple way of solving it. Because sometimes there will be. Because especially with the questions I'm giving you, because I've just pulled this out of my head, I haven't tried to think of a question that has an easy solution. There are some in your 12 or whatever questions up here, 8 questions, that have really simple solutions if you use a certain multiplication or something. Okay, so 21 fits into 33 one time. So we're just starting. We know, because I don't think there's an easy multiplication. Like I could times that by 4 and times that by 4, but that doesn't really help. Times that by 3 makes it 99, and this is 63, 99, 63. You can definitely see some kind of relationship there, but it doesn't help. So let's just do it. Let's just stop mucking around and do it. So 21 goes into 33 one time. So I'm just going to write my 21 times tables down here quickly. Now, if I didn't know my 21 times tables, which I don't, I need to write them down. So 21, 42, so essentially this is going up in 2s and this one's going up in 1s, by the way, because it's a 21. So then I'm going to be 63. And I might just write down to that, down to around that 100 mark. It'll be 84. And I'm going to go right down to that 100 mark, which is 105. Hopefully that should get me anywhere near I need. So I've done that first, and I've written it on the side. If I don't know my times tables for the thing, it's an important step to help you get it right. So it goes in once. And my remainder, 21, so I have 12 remaining, because 21 plus 12 is 33. Just to go over that process, if I took 21 away from 33, I would have 12 remaining. That's just that process, just so you can understand. Now, does 21 go into 12? The answer is no. So I have to put a decimal point in. Oh, and I've accidentally changed my cursor. Just put this decimal point in. Changed it again. Man, I'm really on fire. Here you go. Decimal point. Now, because I put that decimal point, I can put a free 0 on. Now, does 21 go into 120? Well, I just so happen to have already worked that out because I've done my 21 times tables down here. It goes in 1, 2, 3, 4, 5 times. With a remainder of, so how I work out the remainder is I subtract this number from that number. So I have a remainder of 15. Oh no, it looks like I'm going to have to go further up my 21 times tables. So does 21 go into 15? No, it doesn't. But it is going to go, my free 0, I'm going to add into it. So now I've just realized I need to take my 21 times tables at least up to 150. Bit of a bummer, but that's okay. So now I'm just going to add 126. And 147. Just writing them down because I might as well keep them on the side of my page because you never know, this equation might go on for quite some time and I might need them again later. So rather than just doing them in my head and going, oh, 21, 42, 63, I write them down because then I'm going to be able to use them going back to them. So 147, that's 21 more than 126. Let's hope I don't ever make that silly mistake, but it happens. So that's how many times it goes on. So 1, 2, 3, 4, 5, 6, 7. With 3 remainder. Cool. Okay, now I said you're fine to just go to 2 decimal places, but to figure out whether you need to round up or leave it alone, you have to figure out your third one. So I've got 3 remaining. Does 21 go into 3? No. Does it go into 30? Yes, and it goes in 1 time. So 1.571. Now, because I'm rounding to 2dp, it would be 1.57. If I want, and I write 2dp there, 2dp, 2 decimal places. That's an awful P. Perhaps I need to get myself a mouse if I'm going to continue using this program. So that's the actual process there. And again, that would have that has a remainder of 9, but I don't need to carry on doing this. because I'm only having to work to 2dp. So to figure out whether what you're rounding, you need to go to the number past it. So I wanted to round to 2dp. So I worked it out to 3dp. And if this number is less than 5, you just leave this one alone, the second decimal place alone. If it's 5 or more, you round up. Simple. So if that was, just say for argument's sake, it's not, but if it was a 6, my 2 decimal place would be 1.58. I would round up. Rounding's a thing on its own, and it's something to think about. So let's see whether I got it right, because isn't it always lovely to see yourself fail? 33 divided by 21. I really hope I've got this right. Yeah. Whoopsie. Yeah, I do have it right. 33 divided by 20 divided by 21. See, so you'll be able to see that the first 3 numbers I've got exactly right, and if I'm rounding, even on a calculator, if you were rounding that, it would be the same answer. So that's wonderful. So that was a little bit harder. I chose pretty much as nasty as you could make it out of that. So now I'm going to do one with decimal places, okay? Just to show you the process for decimal places. Try and make life a little bit easier. I think I'll have a look at one that is very similar to question 2. I'll make this big, erase it. Again, like I just said before, I want you to make sure that you actually check your answers. I always check your answers anyway. I enjoy it. I enjoy looking at your work and figuring out where you went wrong. So it's not going to change much, other than it just makes you aware of it before I tell you. Because if you're aware of it, you don't go and, like, if you get it all done on Monday, but then you actually go through and mark it and you realize, hey, I've got most of it wrong, then it gives you the rest of the week to work on it. Whereas if you don't go through and mark it, you're just handing in a whole heap of wrong work, and you just can't learn from it. Okay, let's have a look at question 2. 18.9 and 1.7. Cool. So I'm going to do 19.3 and 1.5. They're totally arbitrary numbers. What did I say? 19.3 is my big number. And 1.5. Well, if only I was good at this program. That was a fail. 1.5. Now, the key to this is recognizing when, if there's any easy way to do it. And for this problem, again, because I've just made it out of my head, I can't really see a clear, easy way to do it. So the first thing I'm going to do is I'm going to multiply, because I've got 1 decimal place, I'm going to multiply them by 10, which is essentially moving the decimal place to there, and to there. So these problems become, instead of 1.5 into 19.3, it becomes 15 into 193. So it's exactly the same as what you've just done. There's no difference. The decimal places don't make it harder. And then you'd write down your 15 times tables here. 15, 30, 45, 60, 75, I know them off the top of my head. You might know them off the top of your head as well. It's quite an easy one to know off the top of your head. But it's actually worth writing down if you find them at all challenging, because it just saves you from making a silly mistake and going, oh, it's like, and having the wrong remainder, because you do this process of, oh yeah, I know that I have to subtract that from there all the time. 60, 75. After 75, you got 90. After 90, you got 105. What was the last? We did the 21 times tables had 105 in it as well. Common factors. $120. Oh, that's an awful 105. Might just go to 120. I think that's probably a good place to stop for now. I might need more later, but no need to slow myself down. Oh, actually, I need to at least go to 190, 190, or as close as I can get. So next one, 135. There's quicker ways to doing this than like writing it all down like this, and I would do those, like quicker ways of writing it down. I would do those if I wasn't on camera, but I just want to make it super clear that no matter how good you are or how fast you are, you still need a process. Otherwise, you end up doing something like that, 140 instead of 150. You need a clear process, and it's best to stick to that same clear process. That number was supposed to be 150, and I was busy talking about process and not busy thinking. And if I didn't see that, I could end up putting my whole thing out. And also, if you do this and I look at it and I see that you've made a silly mistake like writing 140 instead of 150, then I can go, oh, you actually did the process right, and I know that you could do it. You just did your 15 times tables wrong, and it's not 140, it's 150. And, just make sure you check your 15 times tables, and it's no big deal. 180. And past 180, it would be 195. 150, 165, 180, 195. I'll write 195 down as well. But as you can see, 195 doesn't fit into 193. So the highest one is 180. So I subtract 180 from 193, which leaves me with 13 as a remainder. So I'm going to write my remainder in. Now I'm going to figure out how many times that goes in. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is my first part. It goes in 12 times. And then I put my decimal, because 15 does not go into 130. So I know I'm going to get a decimal answer here now. And because I've got a decimal, I get my 130. 15 didn't go into 13. So, and it goes into 130. Now I go through my list. 120. So I can count this 1, 2, 3, 4, 5, 6, 7, 8 times. And 130 subtracting 120. I don't mind if you write it up somewhere, if you have to write it up. There'll be lots of people who do. I don't, and there'll be lots of you who don't either. But that's, I know that this goes in 8 times. 1, 2, 3, 4, 5, 6, 7, 8. I know it goes in 8 times. I write the 8 and then to figure out what's left over. And it's 10 left over. Because 130 take away 120 is 8 with 10 remainder. You write the remainder there. Now, how many times does 15 go into 10? Well, it doesn't, but because I'm working past the decimal, I get my free 1, 0. Now how many times does 15 go into 100? Well, that's the 91. So it's 1, 2, 3, 4, 5, 6. 8, 6. And it just so happens to have 10 remaining again. And again, same process, free 0. So how many times does 15 go into this 100 is 6. So 12.866. So Now, if I'm rounding to 2 decimal places, I'm looking at my third digit. Is it 5 or higher? Yes, it is. So I'm rounding up. So my actual answer, rounded, is going to be 12.87. Now, you've got to be very careful that you actually write to... Well, apparently I failed at writing there. 2DP. Oh my goodness, I am awful with this device. It's all over the place. Ah, that's why I'm not in draw mode. P. 2 decimal places. I'm sorry about that. Awful handwriting. It is quite hard to do on a computer, but I think this is more clear, even with my horrible computer hand. It's clearer than when I was doing it with the book. So that's how you do it. 12.87 to 2dp. So once again, just like I'm asking you to do, you would do the problem, and then you would actually ask yourself. So I'm going to write in the original problem, just to show you that the original problem of 19.3 divided by 1.5 gives you the same answer. See, so 12.8666666. So we had 12.866, but we would have kept on going on sixes, and then so we rounded that up to 12.87, which is 100% acceptable. So that's the division portion of the week. Try to make sure that you check that you're doing it the easiest way possible. Hint of the day: if something is finished with a 0.5, sometimes it's easier to actually just double it to a whole number and double the answer to a whole number rather than multiplying it by 10 like we have been doing by moving the decimal. But if in doubt, just move the decimal, because you're going to get the answer right if you just go move the decimal so that there's no decimal points, like we just did then. Hopefully I didn't confuse you by what I just said. Okay, so let's have a look at the other half. The other half is very simple. It's multiplication. And they're easy multiplications, but you need to, well, not super easy. One of the things that is a big part of this, if you've looked at your rubric, which is in the top of your things, is you need to be using these multiplication strategies to solve area and perimeter, well, not perimeter problems, you don't use multiplication to solve perimeter, area and volume problems. There's also some perimeter problems, but we won't be doing them because I think we can all add, because that's what perimeter is. Okay, so the first thing you need to do when faced with this sort of thing is look up how do you solve these problems. So how do you solve the area of a triangle? So let's look it up. Area of a triangle. Now, the beauty in this is it will 100% come up with, yes, it actually has come up with, as I knew it would, it's come up with the actual formula. Height times base divided by 2. So what you can actually do is we can put the answer into a problem. But once again, if you just put the answer in, you're not showing me working, and I'm marking your working, you'll be marked wrong. I don't accept not putting in the thing. What you need to do is you need to do something like this. So I'm going to walk you through the process for this problem. And I'm going to do one for the multiplication of of a circle, because it's a different formula and it's a tricky formula. And then we could talk about this one as well. But again, further you get up, the harder they are, except for this one, which is easy for no real reason. I don't know why I made that easy. Okay, so here we go. Let's write that formula in. First thing we need to do, change our thing. The formula was, I know it off the top of my head, but I'm going to check it again because I want you to see area equals height times base divided by 2. So on my auto draw for a triangle, A area, which is what we're trying to figure out, equals half base times height. Or you can write it how they did. I just wrote it how I knew it rather than how I just read it. Sorry. Base times height times height. Oh man, I'm really awful at this. Divided by 2. So A area equals base times height divided by 2. So what's the base and what's the height? It's real simple. It actually shows you on the diagram. The height is there and the base is there. So I've actually written them all in here. So like that's the base and that's the height. So the height of this one is 3.6 and the base is 4.6. So you're just going to do the old 3.6 times 4.6. So we'll put the bigger number on the top because that's just what I like to do. 4.6. So much slower for me doing it on this device. If it's not clearer for you, I'd like to hear, like, if you prefer me just to write it on a piece of paper with a camera, then that would be great. Save me some time. Now the first thing I'm going to do is I'm going to write that there's two numbers after the decimal place. That means that I can treat it like they're not there and put them in afterwards. 2 numbers after the decimal place. That's my little reminder to myself. And now I'm going to delete them. Goodbye. Goodbye decimal place. For now. Put them back in at the end. So now I'm dealing with it as 46 times 36. Change myself back to black. Now 6 times 6 is 36. So let's do our lines above the top. So I'm going to write the carried numbers for this first one in here, and then if there's carried numbers for the second line, they're going to be written up there. So there's clear separation. So 6 times 6 is 36. So I write the 6 here, and I write the 3 up here. Ooh, that almost looks good. Now 6 times 4, 2 times 6 is 12, double that, 24, plus the 3. Now I have to add, so 6 times 4 is 24, and I have to add the 3. So that's 27. 27. Now because I've done that, I've done my 6's, now I'm working with my 3, that's actually worth 30, so I have to start with a 0. Now, 3 times 6 is 18. So I carry that 1 goes up there and the 8 goes right here where it should be. Now, 3 times 4 is 12, plus 1 is 13. Now I add those numbers together. Whoa, saggy line. I'm going to just Control Z that. So it looks nice. 6 and 0 is 6. Now when I'm adding these numbers, I just carry to this line. That's 15. So I write the 1 up there and 5 here. That's 3 and 3 because those 2 are 3 and that's 3, so that's 6. And that's, did I just, 1. Then I'd put my 2 decimal places back in. And I've just realized that I've actually answered the question for you, which was silly. I should have modified it, so I'm going to have to modify it before I put it up. It'll be very similar to that, but that's the process. just your same multiplication strategies that you've been using. You can use any multiplication strategy you want now because we're talking about solving the problem. So use whatever's best for you. Could have done place value times 3 and then times 6. That could have worked. Times 3 with a 0 added. That could have worked. I wouldn't use tidy numbers for that. I could have tidied it up to 40, but yeah, it wouldn't have helped. The place value could have worked to solve that problem pretty quickly. Anyhow, now we're going to have a look at a circle problem. I won't do the exact problem, and I'm just going to change one of these first. Edit. Come on. Oopsie. I think the fact that I'm streaming at the same time has made it rather slow. Text box, come on. 5.1. So that problem is now completely different, but not same process, exactly the same process. Okay, here we go. So what am I doing? I'm doing a circle one. So exactly the same thing you have to do first. The first thing you need to do is write in your formula. The formula for a circle, area of a circle. I'm going to look it up rather than just write it down so you can see how I'm doing it. It's always the same process. We don't ever just make stuff up out of our head. We always look for the answer, you know? It just makes our life easier. Look it up, write it down. Because just a little slip up, you know, as confident as you might be, you might have just worked out the perimeter of a circle or you know, just the smallest thing. So just use the opportunity. Any tests you get will actually say the formula at your level. You have to, I think, year 11, I think you pretty much have to remember it, but you know, if you've been doing it for a while, you should feel pretty good about it. Oh, actually, before we did that last one, that was 3.6 by 4.6. 3.6 by 4.6, I think it was. I can't even remember our answer, so no, it wasn't there. Ah, it was that. I forgot to undo. Haha. That's great. It's great to make mistakes live. So I was going to go put that decimal place in. But first thing I need to do is divide everything by 2. I've just done base times height. So my next step would actually be, that's a classic mistake, is to actually fulfill the whole formula. That's why it's great to check yourself. Like, you know, I would have just gone and taught you guys all wrong. So I've done the multiplication. But now I need to divide it by 2. So I can fit. How I would do this in my head is I'm just going to go 56 divided by 2. Well, 50 divided by 2 is 25. And 6 divided by 2 is 3. So that's 28 together. And then 16 divided by 2 is 8. So 8.28, which actually gives you the answer that they have up here. 8.28. So we've done the maths right, but I'm going to do it properly for you so you can actually see what I'm talking about. So 16 point. So now we just go and let's rub all this out. Give ourselves a new piece of space to work on. Obviously you would leave it in your book, you wouldn't rub it out. It's just I've got no book. So I've got 1658. Now I'm not going to put those decimal places in yet, which I held my 2dp, because it's easier to work without them, and then I'll put them in at the end as well. So I've still got that written down, the 2dp. Okay, so here we go. So what I'd forgotten was to divide it by 2. I'd just done the multiplication at that stage. I'd done the base times height. Now I hadn't done the divided by 2. So simple problem 16, 28. Now, no, 1656, sorry. Just really lost my concentration. Again, why it's good to have your numbers written down. I'm sorry about this, guys, actually. Really struggling with the technological side of it. I feel like everything's so slow that I kind of lose my train of thought a little bit here. $16.56. Okay. I'm getting rid of that point as well because it's not 0.2. It's how many times does 2 go into 1656? So, treating this like it's really hard to explain. I'm going to break this into its place value because that's the easiest way to solve this problem. Because, well, it is. So you know that 2 goes into 1600. I'm really getting frustrated with this thing. It seems to be getting worse. I'm just going to exit it and re-enter. Hopefully it's sort of... Actually, I might try this one. That is so much better. Hopefully it has an erase tool. It does. Okay, we're on a winner here. This is so much better. Back to the brush. Here we go. So, the problem we still have to solve is 1658. Divided by 2. So the simplest way to do it is 2's into 1600 because you can use place value, ignore the zeros. 2's into 16 is 8. And then add the zeros afterwards. Then 2's into 50. Which is 25, just in case you didn't notice. So 25. That was supposed to be 56. Really fluffing this one now. But this program's much nicer to write with. Twos into 6. 3. So the answer being 825, 828. 828. And then you'd hold that 2 decimal places and put it in. Sorry about that, guys. That was awful. That was absolutely awful. You got the process, and most people probably wouldn't have to watch that anyway. But I think this drawing problem is better. So now we're going to look up area of a circle. Now again, so what it's saying, oh it doesn't, formula, oh there it does, area equals pi times radius squared. So we're going to delete everything off. I like this one, much nicer, it runs much smoother. Cool, and we're going to go have a look at equation 6.8. So one trick with that is diameter is from one side to the other. Radius is halfway. This is 6.8 is already a diameter, so we have to half that to start, which is 3.4. So let's write in this formula. Pi times radius squared. Area equals pi times radius squared. When numerals are written right next to each other, they mean multiply when you're dealing with algebra. But I've written in the little thing just so you can see it. I'm going to write it out nice. Okay. Pi times radius squared. So the radius was 3.4 because it's half 6.8. This one here, just to trick, that radius is already worked out. Okay, so half of 3.4. So now we need to find out what pi is. It's 3.1415, but you can, what number is pi? Boom, it'll come up, 3.14159. The number actually goes on forever. No one's ever found the end of the number, and it's always different. But we're happy with 3.14 for us, because we're doing this to 2 decimal places. So we're going to write down pi as well, how much that's worth. So pi equals 3.14. Oh man, sorry this is so long. I'm trying to do detail, but it's ending up being a drag. So now we just input, and we know our radius is half our diameter. Now diameter, so you just half the 8 and half the 6, which is 3.4. So R equals 3.4. I know some of you guys have all done these problems before, so you might not need help. So now we're going to go 3.4 times 3.4, because that's what squared is. It's a number times itself. Which we're going to treat like 34 times 34. It's the old-fashioned multiplication strategy we've done many times. 4 times 4 is 16. 6. 4 times 3 is 12. 13. 12 plus, because 4 times 3 is 12 plus the 1 is 13. 136 on the first line. Now we go 0 there. And 3 times 4 is 12. 3 times 4 is 12. And 3 times 3 is 9, plus 1 is 10. 6, that line there, 6, 5, 1, 1. Now there's 2 decimal places, so we would have that 2 decimal places in. And then we would simply multiply that by pi. So your next problem would be 11.56 times by pi, 3.14. Again, you would do that same formula. I'm not going to do it for you, but you would just simply go through exactly the same as you've done here. Right, you've got 4 decimal places, so write that somewhere, take the decimal places out, do the exact same thing. I'm sorry this has been such a long video. I feel like it's been the longest video I've ever made. Yes, it has. 50 minutes. I'll tag it so that it actually works. Thanks for watching.